This is how an NPM dependency is declared in package.json file. But wait, which is this format of versioning? This is semantic versioning or SemVer. Let's go and see in detail what are the components of a semantic versioning. As per semantic versioning, the format of release version should be in the form of major.minor.patch release. Patch release includes bug fixes and non-breaking changes or any other code improvements. Minor release includes addition of new features, and this release as well does not break the existing code because it is backward compatible. Major release includes major upgrade to the API software and which have critical implications on the existing code as it breaks the existing functionality. Let's see how these are numbered individually. Patch release. For any new bug fixes or code improvement, the last position or the patch position gets incremented by 1, and if any further bug fixes are there, it will follow the same procedure of incrementing the last version number. For any new functionality, the middle position or the minor position gets incremented by 1 and the patch position gets reset to 0. Because when a minor version is released, obviously at that point of time there will be no bugs. Hence patch will always get reset to 0. Major version. For breaking and non-breaking compatible updates, the first position or the major position gets incremented by 1 and the minor and patch position gets reset to 0. If it gets updated from 9.2.2 to a 10.0.0, it means that this has a breaking change and hence minor version and patch version is reset to 0 and the new version 10.0.0 is being released. What are the benefits of SemVer? With semantic versioning, end user of the public API will be able to make a wise decision on whether the release is a breaking change or non-breaking change for his or her implementation of the code. Secondly, API or software can be released with a much cleaner update. Let us now go to a website which is known as NPM SemVer calculator, and we'll see how we can actually define a patch version update or a minor version update or a major version update in our dependency management file, or let's say package.json in our application. So this is the website. So right now there is a dependency known as lodash is written here, and if we check the versions available for this, we have the major version from 0 till 4 is available. So if you write, let's say example 4.0.0, it will only install your that particular version in your application. If you write 4.0.x at the last position, it will install the latest patch version available for that dependency. And instead of 4.0.x, you can also write 4.0.0 and a tilde sign at the beginning. It will also count for the patch releases. If you write, let's say x at the middle position, then it will count for all the minor releases this major release had. So the major release 4 had minor releases from 0 to 17. So whatever the latest would be present at that point of time, that will get installed. Instead of this, we can also do a create symbol at the front, and it will also list down all the list of dependencies which has a minor change on the major version 4. And if you replace the first thing with a star, it will select all the major versions available till now except those RCs and beta and alpha, because those are like pre-build releases. So this is how you can actually go to this particular website semver.npmjs.com, and you can very well play around with the versions available for a particular dependency, and we'll see that if you change the minor version, what is the latest version of that particular dependency is available, or what is the patch version of that dependency is available. This is it for today's session. I hope you liked the video. If you have liked the video, please like and subscribe the channel.